Okay, we're going to finish our talk about Newton's first law by talking about lessons 1C, 1D, about forces. So, review. First off, first law of motion, object at rest stays at rest. Object at motion continues the motion at a constant velocity unless acted upon by an unbalanced force. That's the textbook definition of Newton's first law. Now, the word that came up yesterday was inertia. Inertia is the tendency of an object to resist changes in its velocity. So its velocity is zero, or if it's not zero and constant, either way, it will not change its velocity because of its inertia or mass. We could also take the word inertia and say tendency of an object to resist acceleration. If its velocity is zero or if it's constant and it doesn't want to change, it doesn't want to accelerate. So when we think about inertia, we think about acceleration, right? It doesn't want to accelerate the more mass it has, which is an interesting concept. So kind of putting that all together, the things that we previously talked about. Remember, acceleration means speed up or slow down. So balance and unbalanced forces. So an object at rest stays at rest. Object motion stays in motion with the same speed in the same direction as acted upon by an unbalanced force. First law. There's a physics book sitting on a table. This physics book's not moving. Gravity's pulling it down, but it's not falling down because the table's pushing right back up. And these two forces are equal or balanced. So balanced forces mean an object will continue in that motion, which in the case of this book is it's at rest. Okay, so the book's at rest because the forces are balanced. If we wanted it to accelerate, if we removed the table, there'd be no force pushing back up on the book. Only force that would be there would be gravity, and the object would fall down. In fact, it would accelerate as it fell, as we've talked about with free fall. So unbalanced forces mean the object will accelerate. Here we go again. We have a person standing on the floor. Gravity's pulling the person down. The floor is pushing up. The person is not moving. So the person has its inertia, is at rest because my forces are balanced. Once again, if I remove the floor from underneath this person, this force no longer exists, and the only force is gravity, which would cause the person to accelerate downward, which we know could be dangerous, right? Depending on how far the fall is. But the key is that balanced forces mean you're at rest or traveling at the same speed. If forces are removed and we're unbalanced, then the object will accelerate. So here's an example of an unbalanced force. We have a physics book on the table. Gravity's pulling down, table's pushing up. This direction up and down, not moving. But if we give this book a push in this direction to the right, it's traveling this way, but it's slowing down. Why? Because of friction. There is a frictional force pushing backward that's slowing this book down. That is the unbalanced force that's causing this book to decelerate, slow down, and eventually will come to a stop. And when it comes to a stop, there'll be no more friction, but we'll still have these two balanced forces. So it'll be at rest, and we'll have balanced forces. So unbalanced forces cause acceleration, either speeding up or slowing down. So one more time, if forces are balanced, you're either not moving or moving with a constant velocity. If we're unbalanced, if the forces are not balanced or unbalanced, you're either speeding up or slowing down, which means you're accelerating. And those are all we need to know for today.